Hey everyone, my name is Candace Bohannon and I'm a senior product architect at AWS. I'm so excited to be here at reInvent talking about a topic that is very important to me. It lies at the intersection of two of my absolute favorite things, cutting edge technology, machine learning, LLMs, along with IDE&E, responsible AI. So as someone who gets really excited about all of these ops things, I was a DevOps engineer, ML ops, now we have LLM ops. I think that it's really incredible the potential that we have here with large language models and AI. Although, with this great opportunity that we have at our hands right now, there's also a responsibility to make sure that we embed these principles of fairness, accountability, and inclusivity into the very fabric of these models that we're creating. So today, we're going to talk about responsible AI and how we can ensure that diversity, inclusion, and equity is woven into every stage of our LLM development. We'll go through data collection, model creation, and model monitoring, making sure that we're embedding this ID&E topics into the entire lifecycle. So I believe by fostering a more diverse and representative tech industry, we can also unlock these new perspectives and make sure that everyone's voices are heard. So by now we've all heard of generative AI at least like 85 times today, and large language models. And what's crazy is the speed at which ChatGPT and these sorts of technologies have infiltrated our lives has been absolutely incredible. According to Reuters, ChatGPT actually grew to 100 million users in just 2 months. So that's faster than TikTok, Instagram, all these other things. And it's just absolutely incredible. So we've all touched it. We've all heard it 85 bajillion times today. And we've all seen something weird happen with it. So whether it was a straight out lie or hallucination, like this clock that I have how about this telephone that I have here on the screen? We have to deal with it in our lives every day. So what's interesting to me about this picture that I have on the slide is that this is kind of the telephone game. That's what I'm trying to illustrate here. So I told Stable Diffusion to generate a telephone for me, and you'll see there the numbers don't actually make sense, right? So it looks like the little kid telephone with the eyes that maybe we had back in the 80s, but it's not right. So we as technologists have to ensure that we are looking at this with a critical eye and understanding and giving the end users as well an indication of when these things are going well or not, the hallucination. So when this model does provide a very confident response, but it's still wrong, that misinformation and skewed perspectives, perhaps prejudice, can continue to infiltrate our lives to the people who are using these technologies. So that's why I'm very passionate and interested in this sort of topic. And so we're going to talk more about how we can detect these biases as well as strategies for remediating them. So here's our agenda. We're going to start with just a simple what is bias, different types of bias, and then we'll look more into LLMs and where the bias can be introduced. We'll also talk more about mitigating bias and give a few examples of what's being done in the industry. So, understanding the bias. Here is the definition of bias straight from Merriam-Webster. So I'm not trying to be creative here. No LLMs are used on this slide. And you'll see in the very first definition, we have a couple of keywords that I wanted you to really pay attention to. So the first definition is very English focused. It makes sense to us as we read that, right? But when we're talking about an inclination of unreasoned judgment, what does that mean from a math perspective? How can we get very precise about that? So that one probably makes sense to most people, but the other two definitions are the one that I kind of prefer as a math nerd myself, and we can actually measure this in a way. So what is the statistical estimate, and what is the deviation from that, as well as that systematic error that can be introduced. So we're going to focus more on those second two definitions when we're going through this because they're just easier to measure overall. So here are a few of the common fairness metrics that are used in the industry today. You can read through those. As Americans, we're very familiar with the English term of equal opportunity. And then there's also, we're in Vegas, right? So we can talk about equalized odds, and then demographic parity. But if you look at the three of these, to the average bear, these might sound very similar. But from a statistical perspective, from the math, these are very different. Very different metrics overall. One example that I find very interesting is a paper from 2017 called Gender Shades. And what they did in that paper, you're probably all somewhat, at least a little bit familiar with this, but what they did in this paper, these two brilliant women, they took faces from African population and Scandinavian population, males and females, and then they ran them through an off-the-shelf facial recognition software. The interesting part is when they blurred out these images, so they made it so you can only see their face. You can no longer see that I'm blonde and wearing like girl jeans, obviously. You can only see their face. They blurred out all of the rest. These off-the-shelf, very well-known computer vision gender models, they kind of suck from our perspective. Like they were not very good at all. They did very poorly on female faces, and they did very poorly on the darker faces. And then when we combine that and look at the darker female faces, they actually misclassified the gender 25% of the time. This is 50% of the sample size there, and they miscalculated it 25% of the time. So it's something that we need to be aware of. We need to be aware that this is just regular machine learning, but they have bias built in. And a lot of that, at least in my opinion, probably comes from where this data came from in the beginning. So if we start to think about the machine learning lifecycle, bringing us back to here, I adopted this from the well-architected machine learning lens. So that's kind of where this comes from. And we're focusing right now on data processing, the data that's being fed into the model. So if we think about these facial recognition, gender classifying algorithms that were created, who do you think is creating these models generally? What does our tech population look like? This is a beautiful, diverse crowd, and it doesn't always look like this beautiful, diverse crowd. So the point here is that if we don't have the good data being fed into our model, then our model itself is doomed to be good at this anyways. It hasn't learned any better overall. So we need to build more inclusive data sets. That's what I'm saying right here. You have to seek out those diverse perspectives, the diverse faces, and make sure that that's balanced out in your data set overall. Sometimes we're going to have to oversample on an underrepresented face or voice or whatever. Now this is where it starts to get just a little bit dicey, right? Because you still need to have the human in the loop, this expert person, making sure that we're not oversampling too far. We want it to be equitable, where everyone has the same rights given to them out just of being a person. So we do need to kind of watch out and make sure that we're not over-indexing too much on females or darker faces or whatever. It's up to us to make sure that we do this the right way. So it's not something that we can overly allow the machines to go crazy on. Another interesting thing, I think, is this contextual and cultural awareness, and we're going to talk more about that on this next slide. Yes. So the previous slide was much more about machine learning in general. Now if we start talking about LLMs, we have a ton of data that these are trained on, just a ton of it. Some of this data is copyrighted material. And another thing about large language models is the authors of these often feel like the data set itself is their secret sauce. So they're not going to show you all the things inside of their model that they use to train this, whether it's because it's copyrighted, it's their secret sauce, whatever that might be. It's an opaque box to us. It's not something that we can just dive into. And so we have to get smarter about how we detect the bias and, again, keep the human in the loop so that we don't mess up this for our end users. Another thing to keep in mind when we're talking about our data sets is that We use a lot of transfer learning because, again, this is a lot of data, a lot of time, energy, money spent to train these models, and so we use transfer learning quite a bit. So I sometimes call them parent models, mama models. I don't know if that's actually correct, but if that mama model, the original BERT model, what has some biased data inside of it, which we can't quite help because BERT is looking at the entire internet, what we do after that is we transfer it down to a child model, and we might accidentally send more of that biased data down to our other models. So it's just another point that I'm trying to make, that these are more complex. And then finally, I mentioned on the last slide the cultural and contextual awareness. This I find very interesting. I learned just a few months ago, actually. Most of our large language models are Western-centric. They're made in the US and Europe, generally speaking. And then when we start to think about multilingual models, like, it's absolutely incredible how complicated that can get as well. I have been trying to learn Spanish on Duolingo for 3 years, and I'm really terrible at it, so let's not try. But anyone who can speak multiple languages, you know there's those semantic differences where when you're translating from one language to another language, you might miss one of those cues overall. So now when we start talking about deploying these LLMs in Asia, we're going to have different language concerns that we need to be concerned about. Maybe the way that we answer needs to be slightly different. There's just different cultural things that we need to be aware of. A blog that I read that I found fascinating on AWS blogs was about using Trainium to fine-tune train a Japanese model. So just Google those words and you can probably find the blog that I'm talking about. But what they found is that when you take a mama model and it was first created in English, and then you try to make it understand Japanese, it gets really, really tricky. And so they walk through how they actually mitigate some of that by using low quality data to start with in English. I believe then they add low quality Japanese data, and then they fine tune train it on the full Japanese data set. It's very interesting, the different approaches we have to take for that. So that is that's kind of the obvious spot. The data being fed in could lead to bias. But actually the model architecture itself, the model development can also allow bias to sneak into our models. So this could happen just based on the architecture itself, the model that you used overall. We can start thinking about, like, neural networks is something from a long time ago where they had those hidden layers overall. Again, that's another opaque spot where we can't even see what's happening in the hidden layers. So there could be something sneaky and bias kind of sneaking in right there. Also, our hyperparameter tuning is another spot where it could affect the overall shape of our model, and so another spot where bias could be introduced. And then finally, the more obvious one for this specific slide is the objective function and loss function. So of course, that's helping us figure out if we're actually reaching the goal that we want for our model, and ultimately deciding when we stop training it, and those sorts of things. So I would say the objective function and loss function are the parts that are affecting our model shape the most. So it's not great. Those are places where bias can be introduced, and you can start to do different things to mitigate it throughout there. And so now we're going to talk more about some strategies to really mitigate the bias. And we're going to talk a bit about model monitoring. And again, we're going to start with old school machine learning. And this is one of my favorite things to talk about. At AWS as solutions architects, we are generalists generally, and then we are supposed to get deep into at least one topic. I can talk to you about DevOps and MLOps all the time if you want. But this is kind of the MLOps side of thing, the model monitoring. How do you monitor for concept drift, making sure that your model is still answering the original question that you thought it was? How can you monitor also for making sure that the data you're feeding into the model still looks the same, whether that is, an int and now it's a float or something like that? And then you can also start monitoring for model drift overall. So is your model still behaving as you expected it to, reaching the accuracy that you expect it to, and those sorts of things? And with all of these things, you need to keep a person in the loop. I keep coming back to that. We can't let it just go crazy. So we have to keep these people in the loop. And with that, I'm talking about monitoring the output. A person needs to be in there Not for every single response, obviously, but a person needs to do some spot checking and making sure that things are still behaving as they're supposed to. We also have different ways of doing these fairness audits, including open source libraries that you can go out and find, so we can automate some pieces of the fairness audits. And then I really like the idea of user feedback and reporting mechanisms. So what I'm talking about there is, when any of your favorite large language model answers you, you can tell it, did this, or he or she asked, did this answer your question, and you can give it a thumbs up or thumbs down. So that's the user feedback and reporting mechanisms. So that should be fed back into your MLOps feedback loop so that we can continue to make sure that our model is behaving. So again, kind of repeating myself a little bit, large language models are harder though. They're much more complex and more difficult to get your head wrapped around. And so here is a spot where with large language models, we can do a different kind of testing. So this one is a little bit hard for me, but we have to realize that there are bad people in the world. Like white hat hackers, they can realize that there are bad people in the world. And this adversarial testing is kind of that piece of it. So when you are creating your large language model, fine-tuning it, or just integrating it within your application, you should also do this sort of testing where you are providing your model, your chat system or whatever, you're providing it with some information that you know is bad, whether that's like drop the database table or trying to get some PII out of it. You need to try to think like the bad guys and make sure that you're testing your system for these sorts of things. Deloitte has some pretty good information about adversarial testing that I read when I was preparing for this, and a specific thing that they talked about was that they were able to trick self-driving cars into misclassifying speed limit signs. So imagine a 30 miles per hour now says 80 miles per hour in a self-driving car in a school zone. This can really get bad if we're not really testing and making sure that we're thinking of this from the bad guy's perspective. So a specific way, here's the AWS piece of it, is that we can go ahead and apply some of these Amazon Bedrock guardrails. There were other announcements that my slides were due several weeks ago, so I don't have slides on all the things. But automated reasoning is another thing that I'm very interested in understanding more about how that works, and so that would be another way that we can mitigate the bias. But the guardrails are pretty easy to use, actually. And so you can make sure that your model is answering in a way that's not toxic. Or maybe you want to make sure that your model does not answer with your competitor's name or something, Ford versus Chevy, these sorts of things. So there are ways where you can make sure, even if I say a bad word to my model, we don't want it to repeat that bad word back, especially if I'm talking about a model that we're using for like a child's application or something like that. Another way that we can do this is with the RAG models, the retrieval augmented generation. So this is something that also we've heard about a lot of times. This is a good approach instead of fine-tuned training. You can just add in your own personal knowledge bases so that your model starts with that the like common general response, but it also goes and checks your specific knowledge bases before it comes back with the answer, whether it's right or wrong. You can do this to make sure that you're getting something that's closer to what you expect from your model. It does introduce a delay, of course, but sometimes that doesn't matter. But RAG is a way that we can do this as well. And then finally, I'm almost out of time. Here are 3 resources in the industry, other stuff that people are doing. So my favorite large language model is Claude. I think that's okay to say. I think it's okay to have a favorite. That's always where I start. He's not always the best, but generally I like him. And at Anthropic, they have this whole concept called constitutional AI, which I think is very interesting. So that is probably my favorite of all of the resources. And then you can also read Chapter 3 on responsible AI from Stanford's Human-Centered AI Index. Kind of gives you some more of these metrics and how do we monitor this and what are we looking for. And then we also have tons of publications on our science blog. So that's the last QR code right there. I hope you got all of those. And I only have 45 seconds left, so I don't have time for questions up here on stage, but I will stand out here for about 5-10 minutes, and I'd be happy to chat with any of you if you have any questions. Thank you.